Hi, welcome to this video. Now we are preparing for the final examinations for grade 10 mathematics. Now this question paper, it's for paper 2, okay? So now let us read the questions together, the statement together, and answer the questions afterwards. Now question number 1, it reads as follows. It says to us, the height in centimeters of a group of basketball players were recorded as follows. Now we have a data that is provided to us. I am sure you have learned the different types of data sets. We have group data, we have ungrouped data, continuous and discontinuous. I hope you're all familiar with that. So instead, they can give you, they can give the questions or the statement, they can give the statements in many different ways, okay? It only depends on the question paper provided. So now we are given the data set. This is the heights of the basketball players in centimeters. So how many basketball players are we talking about? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So that means 13 basketball players, their heights were recorded. So now 1.1 it is as follows. It says to us, calculate the mean height of the basketball players correct to one decimal place. When they say to you calculate the mean height, they can sometimes say calculate the average height. Mean and average, same exact thing. So when you want to determine the mean, you add all of these values and then you divide by the total number of all of these values, okay? So to solve for question number 1.1, we're gonna say x bar, which is mean, okay? It's noted by x bar. X bar is equals to sum of all of these values, which is 178 plus 185 plus 186 plus, I'm not gonna add all of them, I'm not gonna write them all of them, okay, to the last value, which is 185. We're just gonna add them and then divide by the total number of the players that the height was recorded, which is most definitely 13. And therefore, on our calculator, we say 178 plus 185 plus 186 plus 192 plus 194 plus 195 plus another 194, I think, yes, plus 197 plus 201 plus 198 plus 179 plus 190 plus 185. Divide by, okay, let me see, how do we get? Let me confirm the addition again. 178 plus 185 plus 186 plus the 192 plus 195 plus 194 plus, I think I skipped 194. Okay, but it's fine. We get an idea as long as we get to the final answer. Plus 197 plus 201 plus 198 plus 197, 179 plus 190 plus 185. So we have 178, 185, we have 186, we have 192, we have 190, yeah, I skipped it, plus 194, I think. And then we have 195, we have 194, we have 197, we have 201, 198, 179, 190, and 185. And then we get 2,474 to divide by the total number, which is 13. And therefore our calculator answer divide by 13, and then we get 190 comma, they say to one decimal place, okay, comma 3 centimeters. So also note of your units, you are provided the height in units. So I think it's best advisable to always write your answer with the units provided, okay? That's how we solve number 1.1. Then 1.2, where we move to 1.2.1. They say to us, determine the maximum and the minimum heights. Now, when you are given your data in this form, where you want to determine the maximum and the minimum, it's fine. You don't have to rearrange your data, maybe in ascending or descending order. You can just try to look for the maximum value. In this case, I can already see my maximum value. My maximum value is 201, okay? So the maximum, my maximum value in this case will be, let me see, 201 centimeters. And then my minimum value in this case, minimum, it's 178 centimeters, 178 centimeters. Therefore, that will be 1.2.1. Now, 1.2.2, it says to us, determine the median height. When you want to determine the median, make sure that your data set, it is rearranged if it is not arranged, okay, in order. So if it is not arranged in order, rearrange it in order. You can rearrange it in ascending order or descending order. My advice is we always do the descending order, okay, so that we can be able to see where is Q1 and Q2 and Q3. So we do the ascending order. Now, let us rearrange this. How are we going to rearrange this? We're going to start with the minimum, most definitely, to maximum. So you can rearrange it somewhere, because this is just one mark. You can rearrange it on your question paper or wherever, but it's still fine. You can also rearrange it here if you have enough space on your answer sheet. So let us rearrange it. So we have 178, we have 179, we have 185, we have another 185, we have 186, we have 190, we have 192, we have 194, we have another 194, we have 197, we have 198, and then we have 201. Let me confirm. Remember, there are 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 178, 179, 185, 185, 186, 190, 192, 194, 194, 197, 195. And then here we have 195. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Okay, even the exam, guys, confirm, because you can make mistakes. Okay, be careful. So because they want the median height, so meaning we want the middle value out of this rearranged data set, which is now in order. Okay, so to determine the median, we're gonna determine the middle number. So since we have this data set, it is odd because we have 13 data points. So it will be easy for us to locate for a middle value, okay? So now let us try to locate for middle value in this data set. Let me use this. So we have 1, 2, 3, 4, 5, and 6, right? Okay, first 6, because there are 13. I know I'm counting 6 because I know half of 12, it's 6. So that means, okay, fine. And therefore, let us look for, let us go for the other half. 1, 2, 3, 4, 5, and 6. First 6, second 6, and there is a middle number. So the middle number in this case, let me do this. The middle number in this case will be 192. That means, in this case, our median value in centimeters, the median of this data set will be 192 centimeters. Say, for example, you didn't arrange your data set in order, and then you are going to get the different number. You're not even going to be lucky because you can see where is 192 is located. There it is located. You see, you're gonna, even though it's 1 mark, you are going to get your answer wrong. So it is always advisable to make sure that you rearrange your data set in order and in ascending order. Okay. All right, in ascending order, because you're supposed to be able to determine your Q1 and your Q3. That's the thing, you see. All right, so now let us move to question number 1.2.3. 1.2.3 says to us, determine the lower and the upper quartiles of the heights. So we want Q1 and Q3. So Q1, let us talk about Q1 first, the lower quartile. So the lower quartile from the very same arranged orderly data set. For the first half, we're going to determine another half. Okay. So now, when you want to determine when you want to determine the lower quartile or the upper quartile, you do not include or you don't count the median. Okay. So now let us look for Q1. Where is Q1 actually located? So here we have 1, 2. We have 1, 2. Remember, we do not include this one. And then we have 1. Now we have 3. We have 1. Now we have 3. So that means half of the first half is going to be here. It's going to be between 185 and 185. This is where our Q1 will be situated. So that means our Q1 in this case, because we have two values between our Q1, we do not have exact value over there. We do not know how much is it. You just add these two values and divide by 2. You're still going to get 185, but let's do it properly. So you're going to say 185 plus 185, and then you divide by 2. You're going to get 185 centimeters. That's how we determine our Q1 or our lower quartile. Now, to determine the upper quartile of the data set, you use your second half. Now, the second half, you're going to determine its half once more again. So we have 1. We see that it's 3. 1, 2, 3. And then here it's going to be 1, 2, 3. Meaning our median, it's between 195 and 197. So to determine our Q3, I'm saying median of this half, it's actually Q3, okay? So our Q3 of that second half, it will be between 195 and 197. We're still gonna have to divide by 2 because we use two numerical values. So on your calculator, you're gonna say 195 plus 197, we get 392, and then you divide by 2, you get 196 centimeters. That's how we solve this question, which is 1.2. Now we move to 1.3. Let me change my color pen. 1.3 says to us, use your answers in number 1.2 to draw what we call a box and whisker diagram to represent the distribution of the heights of the given group of basketball players. So now we want to represent the data set in a form of box and whisker diagram. We're still doing the same thing, but on what we call box and whisker diagram. Box and whisker diagram, it actually gives us the distribution of the data set, whether the data set will be positively skewed or will be negatively skewed, meaning it will be away from the median, the mode, the mean. That's what we actually want to understand, but we're not going to analyze it yet. We're just going to draw it. So now when you draw a box and whisker diagram, make sure that you open up your scale, okay? So your scale will be based on these 5 number summary. We call this 5 number summary. 1, 2, the median, 3, 4, and 5. We call that 5-number summary. It is the one that we actually represent on a box and whisker diagram. So the timeline that you're gonna open up over here, it solely depends on your 5-number summary, okay? Or you can even use your data. We can see that the minimum is 178 and the maximum is 2. Can we use this one? It's 178 and the maximum is 201. So to open up your timeline, it's supposed to be in in an order, right? In equal intervals. So I will start with, would I start with 175? No, I can't start with 175. I'm going to exclude 178. So no, it's going to be inside. So I can start with 175, right? If I start with 175, that means I'll open up a timeline of using multiples of 5. So it's going to be 175. I'm just adding 5 consecutively. It's going to be 180, 185. Is this going to work? It's going to be less. 185. No, it's going to be less. So I'll start with 175 till, let me see, 175. Yeah, I'll use this because I'm using 5-number summary. This will be perfect, okay? 175, 180, 185, 190, and then here we're gonna have 195. I'm gonna have 200, and I'm gonna have 205 because our maximum in this case is 201. So now let us plot all of these values. Let's start with minimum. Minimum is 178. So I would expect 178 to be between 175 and 180, close to 180 a little bit. So this will be our minimum value, right? Right. You can use your whiskers or you can just use your dots. And so also your whiskers, you can use the vertical line. And then let us go to Q1. Q1 is 185. So most definitely my Q1 will be here. My Q1 will be here. And therefore, let's go to Q2. Q2 is my median, which is 192. So 190 is going to be a little bit close to 190. So my Q2 will be somewhere else over there. And therefore, my Q3 is 196, just close to 195. This will be my Q3. And therefore, my maximum will be 201, just above 200. So it's going to be somewhere else over there. Let me use the dot. And then my maximum will be here. Okay. Let me just use the dot. It's going to be somewhere else over there. Now, let us draw a box and whisker diagram. We just join over there. We just join over there. We link this to that. We also link this to that. So this will be our minimum, and this will be our Q1. This will be our Q2. This will be our Q3. And this will be our maximum, okay? This will be our maximum. Okay, so this will be a box whisker diagram for this question. I hope that was clear. All right then. So now let us try to solve this question over here. All right. I'm trying to think what's happening here. I want to shift something over here on my on this laptop. All right, question number 2, it reads as follows. It says to us, the following frequency distribution table represents the age in years of 63 basketball coaches in a country. So here we have the age, and then here we have the frequency. The thing is, when you add this frequency, it will give you a total number of 63. Now, this 63, it simply means the number of the basketball coaches in a certain country. There are many, and this is the age of all the basketball coaches in that country. So now here's the thing. This data set, um, it is in this form. Okay. Here's the thing. You can write, I mean, like, how many basketball coaches that are 23 in that country? I mean, that are 27. Is 3 of them. How many basketball coaches that are age of 34 in that country? There are 7 of them. Can you see that? So that means this data, it is almost is the same as the data that we have just, but the thing is, we have 63 number of, we can write 27, 27, 27, 3 27s, 7 34s, 12 41s, 19 48. We can't do that. We'd rather do it in a form of a table, which is neat and simplified. Okay. So now we're going to use the table to calculate the mean age of the coaches. Like I said, if this was not in a form of table, we're going to have 27, 27, 27, 34, 34, 34, 34, 34, 34, 41, 41, 42, 48, 42, and then we're going to have to add all of those values and divide by the total number of them. You see, it was going to be a long time. It was going to take us a long time. So now here, how do we determine the mean for 4 marks? Let me show you how we do it. So for 2.1, to determine the mean, which is denoted by x bar, you're going to say 3, which is the frequency, multiplied by 27, plus 7 multiplied by 34, plus 12 multiplied by 41. You will continue, okay? I'm not going to continue. You will continue in your exam. And then I'm going to use the last value, which is 3 multiplied by 69. This is the last term. And therefore, I'm going to add all of these products and divide by the total number of the basketball coaches in the country, which is 63. So, but on my calculator, I'm going to have to include everything. So I'm going to say 3 multiplied by 27, 3 multiplied by 27 plus, right, 7 multiplied by 34 plus 12 multiplied by 41 plus 19 multiplied by 48 plus 12 multiplied by 55 plus 7 multiplied by 62, 62 plus 3 multiplied by 69. And therefore, my calculator, if I did correct product and summation, I get 3024 divided by 63. Therefore, I'm going to say that answer divided by 63, and then I get 48. Yes. Okay. So this is the mean age of the coaches in this country. So we have 48 years. Now, 2.2 says to us, determine the median age of the coaches, the median. Now, here's the thing. Again, like I said, you can't expand this data. You can, only if you have time and only if you will be able to finish up your question paper. So you wouldn't want to expand this 27, 27, 34, 34, and then go to locate for middle number. It's not going to work in that case. So it's going to work, but it's going to take you a lot of time. So this is what you can do. Using the very same table, okay? In order for us to determine the median age, we want the middle age, right? This is what we are going to do. Already our age, it is arranged in order, you can see, from 27 to 69. This is the minimum and this is the maximum. So to determine the Q2, the middle term, using this frequency, you're going to do this, okay? Using the frequency, remember it's 63. And then what is the half of 63? I think it's 31.5, right? This is the half of 63. So we're going to add the frequency until we get to 31.5. So meaning that the 31.5, it is the middle term, but we won't be able to get 35.5 for sure. So I'm gonna consider adding 7, 3, and 12 firstly, okay? So when I take 3, I take 7 and 13, how much do I get on my calculator? Okay, it's gonna be 22. Yeah, it's gonna be 22. I get 22. I'm gonna do the same, moving from the bottom of the table. I'm gonna add 3, 7, and 12. Still, I'm going to get 22. The thing is, I wanna go close to 31.5 as much as I can. But I see that if I move down the table, starting from here, whereby I just added these three values, I got 22. When I add to 19, I'm going to get 41, which is above 31.5. Same applies to here. When I add this 22 to this 19, it's going to be above. So that means certain values from here, when I share them equally, from 19, I can add something to get 31.5. From this 19, I can also add to 22 to get 31.5. So I see that, oh, that means my median is going to be determined by this 19 over here. And therefore, in terms of age, that means I'm talking about 48. Remember, there are 1948. So there is somehow 48 whereby it is in the middle, whether it's second 48 or third 48 or fourth 48, we do not care, but we know that out of these 1948s, the middle one, at the middle term, we're going to have 48. So that means in this case, the median is going to be 40. It's going to be 48 years. Okay, that's how we solve 2.2. Now 2.3 says to us, determine the modal age of the coaches. This is the simplest question ever. The mode, the most appearing or occurring value. You use your frequency. The one that has the highest frequency is the mode. If there were two values that has the highest frequency, that means our mode was going to be those values. So the modal age, here we have frequency which is high, 19. That means the modal age will also be 48. So that means the modal age in this case will be 48. Yes, I hope that was clear. Right then. So now let's continue with question number 3. So now question number 3 says, this is analytical geometry, not Euclidean, okay? Study the diagram, not drawn to scale, below and answer questions that follow. We have a triangle. We have a triangle presented on our Cartesian plane, x and y. Therefore, we are given the vertices of our triangle ABC. The coordinates are also provided. Now, based on this sketch, to answer the questions based on this sketch, okay? Right. So 3.1, it says to us, determine, we're going to do 3.1.1, determine the length of AB. Think of all of the basics that you have learned under analytical geometry. You have learned the distance formulas, the midpoints, all of those things, the properties of your quadrilaterals, properties of your triangles. You know, we have also learned these concepts that the product of the two gradients and what's happening when you talk about the parallel lines. When you're talking about the perpendicular lines, the product is cos -1. The lines that are parallel, they have the same gradient. Okay, those are the basics that you really need to be familiar with when solving these kind of questions. Now 3.1.1, it says to us, determine the length of AB. So from here to there, it's AB. We have the coordinates. We're going to use the distance formula to determine this length. So to determine the length of AB, you're going to say AB squared. I love it doing like this. Doesn't matter how you do this. Okay, you start with the whole sign, blah, blah, it's okay. So AB squared, it's going to be, I'm going to say x of A subtract x of B to the power of 2 plus y of A subtract y of B to the power of 2. You can also do x2, x1, y2, y1. It is still fine. But make sure that you do not interchange the values. If this is x of A, it's supposed to be y of A. You can't say x of A and then there you say y of B. You're going to get it wrong, okay? So they're supposed to correspond. x of b this side, y of b that side. Don't interchange them. Don't mix them. You're gonna get it wrong. Now, what is x of a? X of a is provided to be -5, and then x of b is provided to be +3, negative from the formula, and then y of a is provided to be +8. Y of b is provided to be +2, negative from the formula, to the power of 2. And do not forget that this side you have ab squared, not ab. Okay. Now on your calculator, just plug everything on your calculator. -5, -3 to the power of 2 plus 8, subtract 2 to the power of 2, and then we get 100. Remember, this is not ab. This is ab squared. Now let's get rid of this squared by introducing root sign on both sides. So that means in this case, our AB will be equals to, when root of 100 is 10, right? We're going to get 10, okay? We are not giving in magnitude. You can just write units, it's fine. 10 units. This will be length of AB, which is 10 units. Now, to solve 3.1.2, you're going to say determine the midpoint of AC. Now, where is AC? This is AC. I don't know why they want the midpoint of AC, but it's fine. Let's just do it. To determine the midpoint of AC, okay, midpoint of AC, this is how I do it. Okay, I'm going to say midpoint. It's point M, which is x of M to y of M, which is equals to big, huge bracket. We're going to add the x values. Remember, we want the midpoint of AC. It's going to be somewhere else there. So that means you're going to say x of A, we add the x values, plus x of C, divide by 2, and then same applies to the y values, y of A, plus y of C, divide by 2. Now equate x's to the x's, y to the y's. So that means x of M, in this case, which is what I'm looking for, will be equals to, what is the value of x of A? It's -5, plus what is the value of x of C in this case? It's going to be -3 divided by 2. Now let's look for y of M, which is the midpoint. Y of M in this case will be equals to, what is y of A? Y of A in this case, it's, remember we let M to be this, okay? Y of A in this case is going to be +8, and then y of C is going to be -2. Positive by negative is -2 divided by 2. And therefore 5 plus 8, not 5 plus 8, 5 plus 3 in this case is going to be negative how much? It's going to be -8 divided by 2, you're going to have -4. This will be x of our midpoint. And then y of our midpoint in this case is going to be 8 subtract 2, which is going to be 6. And then 6 divided by 2 is going to be 3. So that means here we're going to have +3. Sorry, it's going to be 5, not 6. Let me do this. It's 3, right? Not 2. No, it's 2. It's fine. It's 2. Now I do not see my writing. So that means we're going to say 8 minus 2. It's 6. And then 6 divided by 2, it's going to be 3. Therefore, the coordinates of the midpoint will be -4 to +3. That was clear. Now we move to 3.1.3. Now 3.1.3 says to us, determine the equation of BC. Where is BC located? This is BC. We want the equation of this line. When you want the equation, remember, this is a linear function. Y is equals to mx plus c. Equation, it is defined by its gradient and y-intercept. This is what we need. This is basically what we need. So firstly, let's determine the gradient. So the gradient of BC, we're going to say the gradient of BC is going to be y of b, subtract y of c, divide by x of b, subtract x of c. Now, what is y of b in this case? Going to be 2. Subtract y of c in this case is going to be -2. It's going to be +2 over there because negative by negative is positive. And therefore x of b in this case is going to be positive 3, and then x of c is going to be positive and negative is negative positive 2. Now we're going to have 4 and we're going to have 5. So our gradient will be 4 over 5. Now we know the gradient. You can determine your equation in many different forms. I like using this one because it's a shorter way of determining the equation. Y minus y1 is equals to, you can say yb or yc, it's fine. Multiply by gradient x minus x2. So I'm going to say this graph, it passes through one of the points. I'll pick this point. I'll say it passes through point B, which is 3, 2. Okay, this is my x and this is my y1. So that means my y1 in this case is 2, and then my gradient in this case is 4 over 5 x, and then my x2 is going to be 3. And therefore 4 over 5 multiplied by x is going to be 4 over 5x. 4 over 5 multiplied by negative 3 is going to be negative 12 over 5. And then I transpose 2 to the other side of the equation, and this side I left with x. Therefore, because we were looking for the equation of BC, we're going to say the equation of BC in this case is going to be 4 over 5x. 2 minus 5 is going to be how much? 5 multiplied by 2 is going to be 10. We're going to have negative, and we're going to have negative 2 over 5. I think if my calculations are correct, it's going to be something like this. This will be the equation of BC, and this will be your y-intercept. You see, here's the thing. Like I said, they say this diagram, it is not correct. It is not correctly drawn. And this value over there, right? This value, we didn't do any mistakes when we were doing calculations. It's true, the gradient is positive, but y-intercept is a negative number. It's not supposed to be negative number, it's supposed to be positive number. Okay, we transpose our 2 to be positive on the other side of the equation, but we ended up with something that looks like this. When we use our point, which is point B, we use the positive value over there. So I realized that this question, it actually has, I think, mistakes in terms of the values provided. It's fine, but what I want you to understand is to catch the drift on how we solve these questions. So here it is actually supposed to be positive number, and our gradient is positive. Is okay. I apologize for that, but you have to know that here is supposed to be positive. Now prove analytically that AC is not perpendicular to BC. Now AC, it is not perpendicular to BC. This is one of the ideas that we need to understand by now, okay? That when the lines are perpendicular, the products of their gradients will be equals to -1. So that means we're going to have to determine the gradient of AC and the gradient of BC. Already we determined the gradient of BC to be 4 over 5, okay? Now we need to determine the gradient of AC. You can also do it in this way. If this gradient is positive, the gradient of AC is supposed to be the inverse, the reciprocal, okay? It needs to be the reciprocal of BC, but in a negative way, since well, this is positive. But you can determine it. Let's just determine the gradient of AC. So the gradient of AC is equals to y of A, subtract y of C, divided by x of A, subtract x of C. So now y of A in this case is positive 8, y of C in this case positive and -2, and then x of A, it's going to be -5. X of C is -3, it's going to be positive 3. Now 8 plus 2 is 10, I think, yes. -5, positive 3, it's going to be -2, therefore we're going to have -5, automatically it's not. Now we're going to say gradient of AC multiplied by gradient of BC is equals to how much? Let's have a look. Gradient of AC is -5 multiplied by gradient of BC. It's positive 4 over 5. So when you multiply them together, we get -4. not -1. You're supposed to get -1. Therefore, the gradient, therefore, AC is not, okay, it's not perpendicular to BC, since gradient of AC multiplied by gradient of BC is not equals to -1. Okay, that's what is happening over here. That will be 3.2. Now 3.4, it says to us, determine the coordinates of point D such that ABCD is a parallelogram. Right. To solve this question, um, to solve this question, point D is a new introduced point. It's going to be somewhere else over here. But let's make sure that this line, because it's a parallelogram, let's just make sure that this line is parallel to that line. And then this line is supposed to be also parallel to that line, and it's going to be something that looks like this. So we'd assume that our point D will be somewhere else over there. So we are not given the coordinates of point D. We do not know the coordinates of point D. It's what we want to do right now. Basically, there are two ways to determine the coordinates of point D. Okay. The first way, which is the longest way, is this way. Just listen. Determine the point D. You're going to determine the equation of BD and the equation of CD. How are you going to determine these two equations? You are given AC. You have already determined the gradient of AC. So now for the fact that this is a parallelogram, we know that these are parallel sides. So that means the gradient of this line is going to be the same as the gradient of this line. Using this gradient and this point, just like here, you can determine the equation of BD. After knowing the equation of BD, you can determine the equation of CD. How? You can determine the gradient of AB. After determining the gradient of AB, remember this is a parallelogram. That means this side and this side are parallel. Therefore, they have the same gradients. So that means that gradient will, again, you're going to perform the same thing. This gradient and this point will help you to determine the equation of CD. And therefore, the equation of DB and the equation of CD, they intersect at this point. You equate them to solve for X and Y. Okay, you can do that. Another way, which is the shortest way, I think, you can use the midpoints. Now, the midpoints of the diagonals of the parallelogram, they intersect equally. Are the same, they bisect. These diagonals, they bisect at this point. So the midpoint is the same. So we're going to determine the midpoint of BC. The midpoint of BC is the same as the midpoint of AD. Okay, so this midpoint of AD will most definitely help us to determine the coordinates of D, because we're gonna have this point and that point, and now we are missing with this point. Okay, so let me erase everything over here. I do not have space. That's gonna erase it. Okay, let me use this diagram. Let me use this side. All right. So now remember, D is somewhere else over there. So let us use the midpoint. So the midpoint of BC, okay, 3.4. The midpoint of BC, we're gonna say, it's gonna call it M. Let the midpoint be M. This is fine. Let me just say, let the midpoint of BC and AD be M. Okay, so meaning when I have M, X of M, Y of M is equals to huge bracket X of C plus X of D divided by 2, Y of C plus Y of D divided by 2. Now let's equate the x's. X of M is equals to X of D, in this case is -3, plus X of D, it's +3 over 2. Now Y of C, it's -2. 2 plus 2 over 2. You're going to get 0. Okay. Now, here's the thing. Like I said, this diagram, okay, the values are missed. Okay. They provided us with, there is a mistake. Okay. There is a mistake in this diagram where I got this question from. So remember, I was given this question paper to be solved. So I wanted to show you, okay, I wanted to perform all of the necessary things that you need to see to show you that this diagram, it is not actually drawn to correct, it's not based on the, like, it's not going to give you correct things, okay? So we get our x to be 0, which this line doesn't even pass through 0. Can you see that? But I hope you understand the procedures on how to calculate these things. That's what I was explaining before I did my calculations. So our x, it says midpoint is supposed to be somewhere else here. So they say x is 0 and it can't be. It really can't be. Okay. The y will also be 0. Okay. The y will also be 0. Okay. This will be a ym. The y will also be 0, which is not what we are actually looking for. So that means if that is the case, that means this line, which is AD, its midpoint will be 0 again. And therefore, we'll be able to determine these coordinates. I hope that was clear. Okay, I'm going to continue with this question. Like I said, I just wanted to perform the calculation so that you can see that this diagram has mistakes. I hope that was clear. All right, then. So now let us continue with this question, which is question number 4. Okay, here we are doing trig trigonometry. Okay, so remember your calculator must be in degree mode, not radians. So refer to the diagram alongside. This is the diagram they're talking about. Okay, P is 3:4. Yeah, on a Cartesian plane, x angle OP is equals to theta. Use the diagram to answer the following questions. So now this is what is happening. Each and every time when you are given your, I love doing it like this, okay, so that can be easier. Draw your right-angled triangle, okay? Let's draw a right-angled triangle. We know that this line is parallel to y-axis and it will act perpendicular to the x-axis. So this line, its y value, it represents line y, which is equals to 4. And then this line, which is also parallel to the x value, to the x-axis, it's a x. This side is x, which is equals to 3. And 3:4. Okay, right. Now the first question, which is 4.1, it says to us, calculate OP from here to there. We're going to use Pythagoras theorem using this right angle triangle to calculate the OP. So we're going to say OP squared is equals to x squared plus y squared. The reason is we used the Pythagoras theorem of Pythagoras. And therefore the x in this case is 3 to the power of 2, and then y in this case is 4 to the power of 2. And therefore it's going to be a 9 plus 16, which is how much? Which is 25, and the result of 25 is 5. So that means we're going to have OP squared. We're going to have 25 over there. Take whole sign on both sides. Therefore, OP will be equals to 5 units. Okay. Now, 4.1.2, it says to us, cot. They want us to determine the cot theta, the magnitude of cot theta. Here's the thing. Cot theta, it is the trigonometric inverse, right? And we know that for trigonometric ratios, we normally use SOHCAHTOA to, when it comes to diagrams like this, to determine the sides, the angles, and all of that. But now here's the trick about the cot. Sometimes you don't know whether the cot is y over x or y over r or x over what. You do not know that. So my advice is, as much as you know SOHCAHTOA, I don't know if it's there out there. But I remember I once did this. Cho, sha, cow. Cho, sha, cow. Okay. So I know this goes with sine, this goes with cos, this goes with tan. So this is the cosecant, this is secant, and this is cotangent. Okay, they go hand in hand. But now here's the thing, as much as you've learned, you see, this is the inverses. OH, this is HO. AH, this is HA. OA, this is AO. These are the inverses of these trigonometric ratios. So if I want to determine cot theta, I need to know whether it's y over x or x over r or what. I need to know that. So cow, it's cotangent. So that means cot theta in this case, cot theta in this case is going to be adjacent over opposite. So theta, this side, it is adjacent to theta and opposite is that one. So that means it is x over y. So that means cot theta will be x, which is 3, over y, which is 4. Okay, that's how we do it. And then 4.1.3, it says to us cos squared theta. So you can rewrite it like this, cos squared theta, and then I don't want to do it like that. Oh, come on. This is how I want to do it. We can rewrite this expression like this, okay? Cos theta and then squared out of the brackets. So now what is cos theta? Cos theta, we know that it's adjacent over hypotenuse. So theta, which is adjacent, it's 3, and then hypotenuse, it's OP, which is 5. So that means we're going to have 3 over 5 to the power of 2. So that means here we're going to have 9 over 25. And then 4.1.4, it says to us, determine 1 minus sine squared theta. Again, we have 1 minus, open bracket, sine theta squared. And therefore, we're going to say 1 minus, what is sine theta? We know that sine is opposite over hypotenuse. Opposite is 4, hypotenuse is 5. So that means we're going to have 4 over 5 to the power of 2. Therefore, we have 1 subtract 16 over 25. And therefore, we're going to have 25 minus 16, it's 9. So we're going to have 9 over 25. Okay, this is 9 over 25. Now, let us do 4.15. We want to determine the 4 cosec theta subtract 3 sec theta. Remember, cho, sha, cow, right? So this is cosecant, this is secant, okay? So here we are dealing with cosec. So cosec, it's hypotenuse over opposite. So yeah, it was 5. So remember, cosec, it's adjacent over opposite. So I have 4 multiplied by my cosec. My cosec is going to be h over o, hypotenuse over opposite to this angle. So that means it's going to be 5 over 4. Subtract 3 multiplied by sec. Sec, it's hypotenuse over adjacent. It's hypotenuse over adjacent. So that means it's going to be 5 over 3. And therefore, this 4 cancels this 4, we left with 5. This 3 cancels with this 3, we left with -5. And then our answer will be 0. So that means the numerical value of this expression will be equals to 0. Hope that was clear. Now let us do 4.2. Now 4.2, it says that if x is equals to 302 degrees and y is equals to 137 degrees, use a calculator and determine to two decimal places the answer to the following. 4.2.1, we want to determine sine 3x, right? So we're going to say sine on your calculator. This is how you're going to actually do it. You're going to say sine 3x. X, they said x is equals to how much? They said x is equals to 302. Okay, on your calculator, you're gonna say 302. I made a mistake here. Oh my god. I'm sorry about that. This is what you're gonna do on your calculator, right? You're gonna say it's 302 degrees, right? You can just close this bracket and say to the power of 3. Okay, to the power of 3, or you can just put your bracket over there. It is still fine. And therefore the answer that you're gonna get is, let's do it, to the power of 3, we get -0, comma, they say correct how many decimal places? 2 decimal places. It's gonna be 0, comma, -0, comma, 61. Okay, that will be 4.2.1. And then 4.2.2, they say to us cos x plus y. Let us substitute. Our x in this case is 302 degrees, and our y in this case, it's, where is it? It's 137 degrees. Just punch this in a calculator, open cos 302 plus 137. And therefore we get positive to 2 decimal places, we get positive 0.19. Okay, and therefore we jump 4.2.3, we have cos x plus cos y. Now x in this case is 302 degrees plus y in this case it's a 137 degrees, and therefore this expression will be equals to, I'm gonna say cos 302 plus cos 137. To 2 decimal place, we get -0.21. 4.2.4, our expression is sec 3x. So remember, cho, sha, cow. We want sec. Sec is here, it's hypotenuse over adjacent. So our hypotenuse, 5, and here it's 3. Our hypotenuse is 5, and our adjacent, it's 3. Okay, so we're gonna say sec this 3 over here, because it's 3 multiplied by x, we're gonna multiply it inside. Okay, we're gonna say sec 3 multiplied by, remember, sec is hypotenuse over adjacent. Hypotenuse is 5 and adjacent is 3. And then we just open up your calculator, you say, oh, by the way, before I forget, okay, let me just say 3 will cancel 3, and then we have sec 5. On your calculator, you don't have sec 5, right? So remember, we have so, ka, to, sec, it is the inverse of cos. Okay, sec is the inverse of cos. So that means here we have, this is sec 5. This is sec, oh wait, we're not using that diagram now. I'm crazy. Now I'm drunk. I apologize about that. I really apologize about that. We're not using the diagram. We are not using the diagram. All right, I'm not feeling well today, but it's fine. So now we're using this statement. So we have sec 3 multiplied by what? X is 302 degrees, and therefore we have sec 3 multiplied by, it's 906. It's 906 degrees. Now we don't have sec on our calculator. Like I said, sec is the inverse of cos, so that means this is 1 over cos 906 degrees, or you can just say cos, or you can just do it like this on your calculator, cos 906 to the power of -1. Okay, you can do it in that way. So that means we're gonna say 1 over cos 906. We get to 2 decimal places, -1, comma 0, 1. Therefore, this will be our final answer for this question.